Okay, afternoon class. Any response dengar tak suara saya?
Dengar.
Tan, why you are here?
Why?
Why you don't choose other chapter?
Other chapter already free.
Okay. So, can we start our presentation now?
Yes, madam.
I start. So today we go through chapter 5, state of matter. Nampak tak apa yang I sharing? Kalau tak nampak bagi tahu, please give me some response.
Tak nampak.
Hello.
Oh, nampak.
Chapter 5, state of matter. So this one, for the PSPM, they have 8.7 marks over the 80. So, katakan chapter ni penting pun quite penting kalau in round off to 40%, that means after lebih kurang 5 markah dalam chapter ini. So, chapter ini ada 5 of the subtopic, right? So 5.1 they have gases and then liquid, solid dengan phase diagram. So ada 4 subtopic ini and then chapter ini ada banyak calculation. Betul tak?
So,
So for this chapter, kelas, sebab I tengah present, I tak nampak apa yang dekat yang Google Meet tu. So kalau ada apa-apa tolong mencela dan tolong tanya je. Hey, please don't just keep quiet because I don't know whether I stop halfway ke, I tak hilang ke, I lost connection ke atau apa-apa. Tolong bagi sikit respon. So for the definition, I have for this chapter, there are some of the definition. Boyle's law, Charles' law, Avogadro law, Dalton law, another vapor pressure, boiling point, phase, triple point dengan critical point. Benda-benda ini you kena tahu definition dia. Hey, even definition is C1, C2, tapi the definition can apply into your calculation. Dia boleh tanya how to apply that definition. And so we go through the definition here. We know that for the gases, untuk gases, kita ada 4 pemboleh ubah kan, PV dengan N and T. P that's mean tekanan dia, pressure, volume, N is number of mole, and then T is temperature. So when you need to explain the gases law yang semua gases law, kalau you nak bagi definition dia, you want to state the gases law, you kena include 4 of the variable ini. Mesti ada keempat-empat ini. Contoh, Boyle's law. Class, am I too fast?
No.
no.
No, okay. Actually, gases law dia tak susah. Gases law hanya A, B, C, D sahaja. If you still remember, A is Avogadro law, Boyle's law, Charles' law dengan Dalton law. So ada 4 gases law. For the Boyle's law, dia mengkaitkan P dengan V. So kalau you nak state the Boyle's law, we know that Boyle's law menyatakan bahawa pressure is inversely proportional to the volume. Betul tak? Dia kaitkan 2 benda ini. Tekanan inversely proportional to the volume. Tapi yang 2 benda ini, you tak boleh abaikan dia. 2 benda ini, you still kena mention in your gases law. You kena bagi tahu, have for a constant number of mole or for a gas at constant number of mole and constant temperature, the pressure of the gases is inversely proportional to its volume. Jelas tak? For the Charles' law pula, kalau Charles' law ialah dia kaitkan V dengan T. Based on the Charles' law, dia menyatakan bahawa volume of the gases is directly proportional to the temperature, but your temperature must in Kelvin kan? So in your definition kamu, you kena bagi tahu for a gases at constant number of mole atau constant mass and constant pressure, the volume of the gases is directly proportional to the temperature in Kelvin, or kalau temperature in Kelvin kita kata apa? Remember yang this term at absolute temperature. Absolute temperature, that means temperature in Kelvin. Boleh tak? Dan kita combinekan yang semua tiga law ini, dia akan membentuk ideal gas law. Betul? So ideal gas law we have PV equal to nRT. And because of the number of mole, the N, we can multiply the number of mole become mass over molar mass kan. So kita boleh multiply equations ini become PV equal to M, MRRT. And we rearrange the equations. Yang benda ini kita boleh mencari MR dia, molar mass, dan juga mencari density dia. So we can modify the equations to get the molar mass and the density of the gases. So I rasa this one tak ada masalah. So boleh kata in this chapter semua calculation adalah berkaitan dengan yang Boyle's law, Chassis law dengan ideal gas law dan juga satu Dalton law. And now we go through the calculation. For the calculation gases law, kita ada the first one. Ini ialah dari mana? Boyle's law kan? This one Chassis law, this one ialah ideal gas law. Betul? So for Boyle's law, this one I want to emphasize the P1V1 equal to P2V2. Unit dia tak penting. The unit can be any unit. The most important is the unit of the P1 must equal to the unit of the P2. Kalau P1 kamu adalah Pascal, so your P2 mesti Pascal. Kalau P1 kamu ialah NM negative 2, so the P2 mesti NN negative 2. Tak kisah you guna unit apa, tak semesti mesti ATM. It's not necessarily must in the ATM. As long as the unit of the P1 equal to the unit of the P2 dan juga unit of the V juga sama. The unit of the volume is tak kisah, boleh apa-apa. Yang penting ialah unit untuk V1 mesti sama dengan unit untuk V2. And then do you know the conversion of the unit? 1 liter equal to 1 dmq. And then 1 ml equal to 1 cmq. Tolong ingat benda ini. After that, all the conversion unit of the pressure, ingat tak? 1 atm sama dengan 760 mmHg atau 760 benda ini tolong ingat Class, am I still with you or not?
Yes.
Ada, sebab I macam dengar sesuatu suara. I takut I lost connection. After that, we have ideal gas law. Chassis law dulu. For the Chassis law, V1 over T1 equal to V2 over T2. So yang ini juga sama. V1 dengan V2, tak kisah dalam unit apa. As long as the both volume must be in the same unit. Tak kisah unit apa pun boleh. Tapi T1, T2, ini mesti dekat Kelvin. It's not apa-apa unit pun boleh. T mesti Kelvin. You know how to change to Kelvin?
Yes.
Ingat yang T mesti Kelvin, tak boleh apa-apa unit. After that, PV equal to nRT, ini juga sama because you need to use the R, the gas constant. Kalau you guna 0.08206, then you need to take notes that T mesti Kelvin and then V mesti liter atau TMQ, mana-mana satu. And then this one P mesti ATM. Kalau nak guna yang unit ini, this one for your R constant, you need to use check the unit of the rest to P dia unit apa, V unit apa, you kena tukar unit this one. Tolong ingat and then PV equal to nRT, kita boleh modify become this one. After that for Dalton law, do you know what's Dalton law or not?
Tahu.
Tahu kan? So Dalton law, actually Dalton law dia tak ada any difference. Kita still apply the gases law dekat sini. Just the difference for the Dalton law ialah Dalton law dia kata campuran of the gas, a mixture of the non-reacting gases. So yang ini refer to the dalam satu campuran gas kita ada banyak-banyak gas. So kita nak cari gas untuk setiap satu ke atau nak cari gas untuk yang total gas tu. So depends on the questions. They ask for the partial pressure of the certain gas or they ask for the total pressure of all the gases. So delta law formula ini dengan formula ini. Formula ini kita guna bila? Dekat mana kita boleh guna formula ini? If you still remember kita ada satu method yang kita namakan water displacement method where we collect the gases over the water. So this one we use the formula, the first formula. Next, after the explanation, kita ada basic assumption of the kinetic molecular theory of the ideal gas. What is the basic assumption of the kinetic molecular theory? So kita ada A, B, C, and T. Tolong ingat yang ini, A, B, C, T. A refer to the intermolecular forces. B is the molecular volume. C refer as the collision. T is the temperature. For the basic assumption of the kinetic molecular theory, they stated that the intermolecular forces of the gases can be negligible. And B is the molecular volume. The molecular volume of the gas particle, you can say that the volume of the gas particle can be negligible compared to the volume of the container. After that, C is the collision between the gases particle are elastic and they have the elastic collision. T, as the temperature higher, average kinetic energy become higher. Boleh tak? So this one, the basic assumption of the kinetic molecular theory. And then ideal and the non-ideal gas behavior, this one ialah in terms of the intermolecular forces and the molecular volume. Intermolecular forces, that's mean A, yang ini bermakna P. Yang ini juga sama dekat when there was equations. Kamu do you still remember the when there was equations? Apa? Ada tak?
Ini mau ingat ah.
Do you still remember the when there was equations? Mestilah ingat. So you need to know what is A, what is B. A, this one refer to the intermolecular forces. B refer to the molecular volume. That's why I guna A, B dekat sini. You kena tahu A bermakna intermolecular forces. B, that mean volume of the gas particle. Because of the real gas dengan ideal gas and the real gas, dia ada difference dekat dua benda ini. That's on the real gas, you kena ada A, kena ada B dekat sini. Real gas, that mean we cannot ignore the intermolecular forces that exist between the gas particle. Betul? Untuk real gas juga, that mean you kena ada molecular volume. Semua gas particle mesti ada volume dia. Kita tak boleh kata dia tak ada volume. So this one is the difference of the ideal gas and the non-ideal behavior of the gas. And satu juga kalau dia kata basic assumption of the kinetic molecular theory of an ideal gas, and this one akan sama dengan cili untuk ideal gas. Kalau dia kata state the characteristic of the ideal gas, so dia sama juga. Adalah 4 yang ini. Faham tak? Basic assumption of the kinetic molecular theory of an ideal gas, jawapan dia mesti sama dengan characteristic of an ideal gas. Sebab dua benda actually refer to the same things. Okay, and the ideal and the non-ideal behavior of the gases. Mengapa ada ideal gas dengan real gas? Sebab real gas ada intermolecular forces, ada intermolecular volume. Tapi untuk ideal gas kita abaikan dua benda ini. Okay, after that, the condition where the real gas approve the ideal behavior, this one you tahu kan? Apa kan condition dia? Temperature kena tinggi, pressure kena rendah. Mengapa temperature tinggi? Dan dua benda ini juga kena explain in term of the A and B. Kalau temperature dia tinggi, bermakna kinetic energy dia tinggi. So when the temperature higher, kinetic energy higher, the particle able to vibrate faster. As the result, they able to overcome the intermolecular forces. So that kita boleh abaikan intermolecular forces dia. Sebab kinetic energy dia boleh overcome the intermolecular forces dah. Untuk pressure pula, kalau pressure dia lower bermakna volume dia besar. So the volume of the container dia sangat-sangat besar. So the volume occupied by the gas particle can be negligible. Sebab volume occupied by the gas particle akan become very small compared to the volume of the container which is very large. Faham tak? So yang dua benda ini you kena explain in term of the intermolecular forces dengan yang molecular volume yang ini ya. After that, you kena kaitkan intermolecular forces dengan vapor pressure with the boiling point. You tahu perkaitan tiga benda ini kan? Kalau intermolecular forces higher, vapor pressure become lower. So boiling point become higher. After that, all the process after vaporization, condensation, boiling, freezing, melting, sublimation, deposition. Semua proses ini you kena tahu juga. After that, for the phase diagram, anomalous behavior of the H2O. So this one is some of the explanation you kena tahu dekat chapter ini. Can we proceed?
Yes.
And then compare real gas and ideal gas behavior. This one just like what I told you tadi, sudah Aisyah bagi tahu kan? And the property of the gas, liquid and solid, and then amorphous, and the crystallized solid, and then phase diagram of the CO2 and the H2O. After that, jenis solid kita tu crystallized solid and the crystallized solid with the amorphous solid. So dua benda ini, what is the difference? Crystallized solid ialah dia in the orderly arrangement. So this one ialah dia is not the orderly arrangement. So yang ini maba amorphous solid boleh berlaku sebab kita you tahu tak mapa dia berlaku? Why this one berlaku? Why this one berlaku? Crystallized solid ini boleh berlaku sebab proses pembekuan the freezing process is very slow and very take time. So that's why dia boleh cool down dengan perlahan-lahan so that the particle can arrange in the very orderly arrangement. Amorphous solid pula sebab the cooling process is very fast. Dia tiba-tiba boleh kata tiba-tiba sejuk. So that dia tak boleh susun lagi particle itu. So that's why the particle is not in the orderly arrangement. So there's a difference in the formation of these two types of the solid. After that, yang crystallized solid ada 4 jenis. Tolong ingat keempat jenis ini. Metallic solid, ionic solid, molecular covalent solid, and giant covalent solid. So normally this one, for setiap satu kalau boleh, I suggest that you hafal satu contoh dia. Metallic solid, you remember one of the example, and then ionic solid apa ke example dia, molecular covalent solid pula what is the example, and then giant covalent solid what is the example. So tolong ingat setiap satu at least ada satu example. So when they ask for the example, you can write the example for each of them. Boleh?
Boleh.
After that, this one is the comparison dia. Just now, I kata ada satu table for the comparison kan. So this one is the comparison dia. And you can go through the comparison, tengok yang semua benda ini. I rasa ini sangat common dah. I tak payah bagi tahu benda ini. Okay, you just go through this one. Next, Atau ada anything yang tanya tak before we go through the next?
No, madam.
Next one then. Okay, and then we go through example questions and answer. A 10.0 liter cylinder contains 4 grams of hydrogen gas and 28 grams of nitrogen gas. So if the temperature is 31 degrees Celsius, determine the total pressure of the gas mixture. So this one, gas mixture, that means this one we apply the Dalton law. Yang ini ya Dalton law. calculate the partial pressure of hydrogen gas. And what will happen if the gaseous mixture is heated to 550 degrees Celsius? So first thing, kena buat apa dulu? They give you the gram. This one we have two gases, hydrogen gas and the nitrogen gas. And then they give you the volume of the container and you have the temperature. Determine the total pressure. They ask for the P total. So first thing, kena cari. Of course, we need to use this one is a PV equal to nRT, right? Formula ini. Tolong ingat kalau tak ada apa-apa idea pun tolong tulis formula, jangan biarkan kosong. I write the formula first. This one of course we need to use this formula, but because they ask for the total pressure, that means this one is stand for the P total. Kalau P total, so N mesti N total. So nak cari N total, that means kena dapatkan bilangan mole hydrogen gas, you need to get the number of mole of the nitrogen gas. So get the number of mole of these two gases. So this one answer dia. First, get the number of mole for the hydrogen gas. Get the number of mole of the nitrogen gas. After that, get the N total dia. After that, tulis formula PV equal to nRT, ganti. So you get the final answer. This one is a P total. Remember, final answer must have the unit. Unit kena betul. So this one is in Kelvin. So this one for first one. So normally markah dia dekat get both of the number of mole. Normally this one ada satu markah and then N total this one got another one marks. After that you write the formula. After that final answer must have the unit dia. Tak ada unit that's mean salah. Kalau banyak markah lagi, maybe substitution they give you 1 mark. Second part, the partial pressure of the hydrogen gas. You need to get the partial pressure. So you should have the P total dah, and you have the N total. So you can use the formula. You tahu tak formula ini formula apa? Dalton law. Ini. Partial pressure for the gas A sama dengan mole fraction of the A darab dengan total pressure dia. Sebab kita sudah ada total P total dia that we have already calculate the P total. So we just make use of the P total, kita calculate from the first part. So letak dekat sini. Mole fraction bermakna number of mole of that particular gas divided by the total number of mole. So yang ini bermakna number of mole of the A divided by the N total. So since you want to calculate the partial pressure of the hydrogen gas, so you have the number of mole of the hydrogen gas divided by the total number of mole of the gas. So from that you get the answer. Okay, and the third part, kalau temperature dia higher, what happen? So temperature higher, gas particle akan gain higher kinetic energy and then vibrate faster. So kalau dia boleh vibrate faster, that means frequency of the collision akan become higher. So pressure akan increase. Betul? Jangan ingat temperature tak ada kaitkan dengan pressure. Temperature kaitkan dengan pressure juga. Okay, so we proceed to next. Write the ideal gas equation for one mole of gas and state 2 assumptions made in the ideal gas equations. Explain how the assumption in 3B, actually this one equation 3 I picked from the past year, are addressed for the ideal gas, for the real gas in Van der Waals equation. So this one is known as the Van der Waals equations. So what is the ideal gas equation for one mole of gas? PV equal to nRT, betul tak?
Yes.
So kalau tulis macam ni bermakna salah. That means you tak faham soalan. Sebab dia sudah kata one mole of gas. One mole of gas, that means your N equal to 1 is it? So if your N equal to 1, that means PV equal to RT. So this one is the answer. You tulis macam ni baru boleh dapat 1 markah sahaja. You tulis macam ni bermakna salah. Do you get what I mean or not? Faham tak? So tolong baca soalan betul-betul. If they ask you, write the ideal gas equation for the gases. So baru kita guna PV equal to nRT. Tapi seperti yang kata for one more of gases, so your N kena tukar menjadi 1. Boleh? And so this one is the answer. So since your N equal to 1, so your PV equal to RT, so this one you get 1 marks. After this, the second one, what is the questions? Assumption made in the ideal gas equations. What is the assumption? So assumption dua benda ini. Intermolecular forces between the gas particle can be negligible. And the volume of the gas particle can be negligible. So intermolecular forces, that's mean A. Volume of the gas particle, that's mean B. Tak boleh kata volume sahaja, mesti kata volume of the gas particle. Mesti ada gas particle. Kalau tak nak guna gas particle, boleh guna gas molecule. Tapi mesti refer to that particles. Volume of the gas particle can be negligible compared to the volume of the container. Kelas yang utama apa kita assume that volume of the gas particle can be negligible or not? Actually yang ini berkaitan dengan C ya. So kita kata collision dia apa dia move randomly kan, dia randomly move. So kita assume that all the gases akan occupy all the spaces in the container. So sebab gas ini dia tak ada intermolecular forces, and sebab gases dia boleh move randomly. So we can make assumption that the gases particle akan occupy all the spaces in that container. That's why the volume of the gas particle equal to the volume of the container. Kita akan ambil volume of the container as the volume of the gas. Boleh? And then see this one explanation dia panjang sikit, so you can go through. So first kita kena explain what is A dulu. A itu stand for what, and then B adalah apa. Kena explain dengan dua term ini. A, that means the intermolecular forces between the gas particle. So the pressure is decreased by the factor of the N square A divided by V square, which account for the intermolecular forces between the gas particle. So ini intermolecular forces between the gas particle. Actually, this one is the A. Apa atau N kuasa 2A, N kuasa 2, that means number of mole dia. Semakin banyak gases, mesti semakin banyak intermolecular forces, betul? So that's why N adalah satu faktor yang mempengaruhi intermolecular forces. Satu lagi ialah V. V that's mean volume dia. Volume juga akan mempengaruhi intermolecular forces, and then the volume dengan intermolecular forces adalah inversely proportional. Sebab kalau volume dia decrease, that means the gas particle mesti pack dengan lebih closer kan. So particle pack closer, that means akan ada intermolecular forces dia. Semakin kecil volume kita, semakin particle akan dekat. So kalau dekat particle itu, bermakna intermolecular forces akan become stronger. So semakin close of the gas particle, semakin stronger of the intermolecular forces. That's why intermolecular forces ada dua faktor dia. Satu ialah bilangan mole dia. Semakin banyak bilangan mole gases, semakin banyak intermolecular forces. Semakin kecil volume dia, semakin stronger of the intermolecular forces yang dia boleh rasa. That's why faktor ini ada N2, N kuasa 2, darab dengan A divided by V kuasa 2. Dengan itu, because the presence of the intermolecular forces, so the P real mesti less than the P ideal. Betul tak? Sebab the intermolecular forces dah. So the collision in that gas particle is not lagi randomly kan, dia tak boleh move dengan randomly sebab the intermolecular forces dah. Ada daya tarikan antara mereka, so frequency of the collision mesti berkurangan. So if the frequency of the collision decrease, that means tekanan dia mesti berkurangan juga. That's why P real mesti less than the P ideal. So that P real equal to this, P ideal equal to this one. And that's why dekat when there was equations, kita ada yang ini, dekat yang P, kamu the corrector of the pressure. After that, for the B polar, B is the apa? The volume occupied by the gas particle. So this one is the B. So the volume occupied by the gas particle mesti dipengaruhi oleh bilangan mole dia. Semakin banyak molekul mesti volume semakin besar kan. So that's why kita ada NB. So we gas, that means the volume occupied by the gas particle. So the gas particle has a certain volume and to occupy some spaces. So the volume is decreased by the factor of NB. N that's mean number of mole, B that's mean the volume occupied by the gas particle. So that the V real that's mean volume yang betul-betul boleh berlaku collision akan become lesser. So the V real equal to the V container minus the V gas, the volume that occupied by the gas particle. Boleh? Any questions? Next, so this one to get another passive questions. A gas mixture content of 82%. W over W nampak familiar that this one, what is this? And this one is what you learn for the first chapter, percentage by mass. So tolong ingat percentage by mass. Tak semestinya mesti guna dekat larutan kita. Not necessarily must in the solution. There can be the mixture of the gas. As long as dia adalah satu campuran, dia boleh ada percentage by mass. So a gas mixture contain 82% percentage by mass of the methane gas CH4 and 80% of the ethane C2H6. Kalau sampel ini, the total mass of this sample ialah yang ini, and then this one is the volume of the container, and this one is the temperature. The total mole of the gases. Second one, the total pressure in the ATM, and then the partial pressure of each gas in the container. So first thing, what you need to do? You need to get the total number of mole, the total mole of the gases. You mesti ada mass dia kan. So dia sudah bagi total mass dah. So by using this mass, and then by using the percentage yang given percentage, tolong calculate the mass of both of the gases. So ini answer dia. So first we calculate the mass of the CH4. CH4 82%, isn't it? So that means dari 15.50 gram ini 15.50 gram ini 82% adalah CH4. So by using this, kita boleh calculate the mass of the CH4 adalah 12.71 gram. After that, convert to number of mole. Convert to number of mole, that means divided by the molar mass kan. After that, by using the same method, we find out the mass of the C2H6. So the total mass times the 18%. Dekat 15.50 gram ini 18% adalah C2H6. So that we use this one darab dengan 18%. So you get this one. After that, convert the number of mole, so you get this one. So the total number of mole, that means summation of the both of the number of mole. So hasil tambah dia, you get the total number of mole. After that, this one juga very simple. Since you have the total number of mole, so you boleh ganti dekat sini. You need to get the P total. V given in the questions is 15 liter and T pun dibeli dah 20 degree Celsius kan. So you tukar je. Convert the unit degree Celsius into Kelvin and this one 15 terus guna. So you get the P total. After that part, the third part, calculate the partial pressure for each of them. So this one kita still we use the Dalton law. Ingat tak apa formula ini? So we apply the formula. Guna formula yang ini. CH4, the number of mole of the CH4 divided by the total number of mole. So you have this one divided by the N total. Darab dengan P total dia as we calculate tadi from the part, second part. So you get the partial pressure of the CH4 is this one. After that, partial pressure of the C2H6 pun boleh guna cara yang sama. The number of mole of the C2H6, this one, divided by the NT, the N total, darab dengan PT. Other than this one, you tahu tak ada apa cara lagi to get this one? Kalau I tak nak guna formula ini, if I don't want to use this formula, is there any other method that I can get the partial pressure? Ada any idea that? Okay, tak ada. So to get this actually from tadi, you start belajar Dalton law. P total equal to P CH4 tambah dengan P C2H6. P total you sudah ada dekat sini dah. So you have the P total here. And from the first part, you start calculate the P for the pH4 kan. CH4 so boleh tak dapat yang ini. P total minus this one, straight away you get this one. So actually tak payah guna rumus ini pun tak apa. Kalau you sudah nampak the application of the Dalton law, actually you can use this one. So P C2H6 equal to the P total divided the P CH8 divided and minus the P CH4. So you still will get the same answer. Boleh, so this one I show you two method to selesai masalah yang ini. Next, so this one I mentioned that the water displacement method. By using the water displacement method, jumpa water displacement method je tolong ingat yang ini. PA equal to PT tolak PH2O. Ingat yang ini. Apa yang diberi dekat sini? What is the pressure? The pressure that given in the questions must refer to the P total. So this one is the PH2O. And kita ada temperature. And kita ada volume. So very obvious, you have P, you have V, you have T. So you need to use the formula PV equal to nRT. And they ask you what calculate the mass of the high oxygen gas. So first, the answer mesti ada benda ini must have this or this thing in order to get the answer. So yang ini kena tulis, jangan tak tulis. This one untuk menunjukkan you faham application of the Dalton law. So yang ini kena tulis. After that, by using the equations ini, guna formula ini, ganti-ganti you find out that the partial pressure for the oxygen is this one. After that, convert to the ATM. How to convert to ATM? Divided by 760 mmHg. So we convert the mmHg to the ATM. After that, use the ideal gas law. Guna ideal gas equations ini PV equal to nRT. And then get the N. Ganti-ganti je semua sudah ada dah. Just ganti-ganti substitute the correct value. After that, you get the number of mole. Once you get the number of mole, of course, you can get the mass. Betul? So, darab dengan molar mass, you get the mass of the oxygen gas. So, actually, the calculation for this chapter, dia tak susah. And we apply the same formula. Kebanyakan guna formula yang sama sahaja. And next. Define boiling point and table 1 show the vapor pressure of the compound A and B at T degrees Celsius. Which compound has a higher boiling point? Explain your answer. A and B, mana compound ada higher boiling point?
A.
Kenapa?
Because the higher the boiling point, the lower vapor pressure.
Okay. Tapi yang keyword saya ialah apa? If you want to kite the vapor pressure to the boiling point, tolong jangan lupa yang perkaitan dia. Perkaitan dua benda ini mesti kaitkan dengan intermolecular forces. So in your explanation mesti ada benda ini. Sebab vapor pressure boleh kaitkan dengan boiling point boleh kaitkan dengan vapor pressure. The terms yang kata kunci dia adalah intermolecular forces. So this one is the answer. Boiling point, what is boiling point? Temperature where the vapor pressure of the liquid equal to the external atmospheric pressure. Tolong ingat yang definition ini. Definition ini sangat penting sebab nanti you nak explain dia, katakan apa, ada banyak explanation ini, you kena guna yang ini. Nanti I bagi satu example. So and this one for the answer for B, vapor pressure A is lower than B. So means that B is easier to escape as the vapor compared with A. So A has the stronger intermolecular forces. So more energy required for A to overcome its intermolecular forces. So that's why boiling point for A is higher than B. Jelas tak? Sebab vapor pressure untuk air adalah lebih rendah. Vapor pressure rendah bermakna bilangan vapor dia sikit. Mengapa bilangan vapor dia sikit? Sebab dia susah nak menjadi vapor. Mengapa susah menjadi vapor? Sebab intermolecular forces dia very strong because they have a very strong intermolecular forces. So kita perlukan banyak-banyak tenaga baru dia boleh escape as the vapor. So that bermakna boiling point dia tinggi juga sebab intermolecular forces dia strong. Boleh faham tak? So mesti kaitkan dengan intermolecular forces. So this one is a very important point dia. Nak tanya apa-apa? Kelas. How to apply this one? Contoh kalau dia bagi satu soalan dia kata, katakan nanti ya, I fikir dulu apa soalan yang sesuai. Let's say for example, they give you sama juga, they give you A, B, and this both compound ini A katakan have vapor pressure, dia kata they give the vapor pressure, both of these they give the vapor pressure too, they give this one vapor pressure 70 atm. This one ialah katakan 20 atm. And they ask you, explain why B, so vapor pressure B is lower kan? Explain why B has a higher boiling point. If they ask you, tolong explain why, mengapa B has a higher boiling point. So you nak explain macam mana?
B has stronger intermolecular forces.
So, kalau nak guna terms ini, kalau nak guna balik point ini, in your explanation, you kena bagi tahu, since vapor pressure for B is lower, that means B has stronger intermolecular forces, right? So more energy required for the B to overcome the intermolecular forces. So the temperature for the B where the vapor pressure for B is equal to the external atmospheric pressure is higher. So that boiling point for B is higher. Faham tak? You kena masukkan ayat ini kalau dia explain, you minta explanation mengapa B higher boiling point dia, you kena bagi tahu yang ini. Sebab intermolecular forces is stronger, that means they require more energy to overcome the intermolecular forces. So the temperature for the vapor pressure of the B to equal to the external atmospheric pressure mesti higher. That's why boiling point is higher. Boleh tak?
Boleh, madam. Boleh.
After that we go to this explanation. Ini semua proses ini juga perlukan explanation. So how to explain the process? Explanation all the process mesti ada semua point-point ini, mesti ada temperature, kinetic energy, molecular motion, intermolecular forces dengan phase change. Contoh kita nak kata boiling. If I want to explain the boiling process, you kena bagi tahu as temperature higher, gas particle gain higher kinetic energy. So when the kinetic energy is higher, particle vibrate faster. Vibrate faster, that's the molecular motion dia. Particle vibrate faster when the kinetic energy is sufficient to overcome the intermolecular forces. So the liquid change to gases. So that's mean boiling. Faham tak? So mesti ada kelima benda ini in your explanation kamu. As the temperature higher, kinetic energy higher. So particle able to vibrate faster when the kinetic energy is enough to overcome the intermolecular forces, liquid change to gas. Boleh faham? Kalau melting pun sama, temperature higher, kinetic energy higher. So molecule atau particle vibrate faster when the kinetic energy is sufficient to overcome the intermolecular forces, solid change to liquid. Kalau freezing macam mana?
When the temperature drop, kinetic
And when the
energy
temperature lower, kinetic energy lower. After that,
kinetic
particle
energy
vibrate slower.
with the
When the
molecule
yang ini jangan kaitkan yang ini ya. When the intermolecular forces is sufficient to hold the particle in a fixed and orderly arrangement, liquid change to solid. Dapat tak? Kalau solid, liquid and gas. Kalau solid kita katakan fixed and orderly arrangement. Fixed and orderly arrangement. Kalau liquid kita statekan dia arrange closer. So katakan kalau freezing that's mean from the liquid change to solid, isn't it? Betul tak? This one yang freezing. So kita boleh kata temperature lower, kinetic energy lower, particle vibrate slower when the intermolecular forces are strong enough to hold the particle in a fixed and orderly arrangement, liquid change to solid. Yang ini bermakna freezing. Kalau condensation that mean gases change to liquid kan? So boleh guna yang ini juga. When the temperature lower, kinetic energy lower atau decrease. Atau weaker. Temperature lower, kinetic energy lower. So particle vibrate slower when the intermolecular forces are sufficient to hold the particle closer. So gases change to liquid. Faham tak?
Faham, madam?
So ingat yang ini ya, kalau gas change to liquid, kita kata intermolecular forces dia able to hold the particle closer. Kalau liquid change to solid, that means the intermolecular forces is sufficient to hold the particle in a fixed and orderly arrangement. Kalau gas terus menjadi solid pun sama. Asalkan dia bertukar menjadi solid, kita kata intermolecular forces sufficient to hold the particle in a fixed and orderly arrangement. So Yan, kalau gas change to solid bermakna proses apa? Apa nama proses tu, gas change to solid?
sublimation.
Deposition. Gas sublimation ialah solid change to gas. This one ialah solid to gas. This one gas to solid. I had this one sketch and label a phase diagram. Determine whether liquid air or solid air is denser. Explain your answer. So this one for your phase diagram. I rasa, for me, I rasa dia macam tak akan keluar je. Sketch and label the phase diagram, tapi mana dalam nanti dia keluar. So they give you some of the important point, melting point, what is the melting point, boiling point, and then critical point, and then triple point. So nak lukis phase diagram macam ni. And normally they ask you to sketch the phase diagram. Kalau sketch bermakna kita boleh sketch dekat yang full sketch pun tak apa. Tapi kalau ada perkataan suruh plot the phase diagram bermakna kena dekat kertas graph. So biasa markah dia sangat tinggi, ada both axis. So both axis mesti with the correct unit sebab dia sebagai unit dah. So tolong tulis dulu, and then shape of the graph mesti bentuk yang betul. Bentuk tu hanya dua jenis sahaja. Satu ialah bentuk macam ni. Kan bentuk yang ini, yang garis yang ini, garis this one yang the difference one. First ialah macam ni, garis dia ke sini. Another one ialah jenis yang ini, garis ke sebelah sini. So actually phase diagram memang dua bentuk ini sahaja. Tengok mana satu yang bentuk yang betul. This one shape of the graph and then label. Mesti label phase and then label semua points yang given. All the given point mesti label. After that they give you answer. They ask you liquid air denser or the solid air denser kan. So from this one tengok sebab yang this one mana denser, mana yang menentukan denser. Garisan mana yang menentukan dia denser or less dense?
Garisan berkumpul.
Which one? Garisan yang ini kan? So garisan yang ini menunjukkan mana denser atau mana less thinner. So based on this one, because they're negative stroke of the melting point temperature, the melting temperature is pada negative, that's why liquid air adalah denser. So this one, if they give one example of air, what is air? So bermakna air adalah H2O. In our syllabus, A sahaja yang ada properties like this. Tolong ingat. The rest dia semua adalah macam ni. Phase diagram yang normal adalah bentuk like this. Dia mesti, yang this one mesti positif stroke dia. Okay, hanya H2O saja yang negatif. So negative stroke of the melting temperature atau melting temperature the decrease with the increasing of the pressure. So kita boleh guna term yang ini. Atau kita boleh bagi tahu melting temperature dia decrease with the increasing of the pressure. So based on this one, you boleh nampak tak? Kalau pressure dia semakin meningkat, temperature akan semakin menurun. Faham tak? Any questions?
No, madam.
Kalau tak ada, I rasa sampai sini sahaja. Other than that, ada tak apa-apa you nak tanya? Is there anything you want to ask?
Madam, yang dekat PV, dekat formula PV and RT tu, V tu ambil V total madam. Kalau nak kira.
Kalau you nak cari P doctor, mesti guna V doctor. V ada satu je kan? V ialah V container.
N pun guna N total juga.
Apa?
N pun N total juga lah.
Ya, kalau P total, M mesti N total. V mesti V total. And then V actually, V tak kisah V total ke atau V apa, V mesti satu je. Sebab all the gases in the same container. So V dia mesti satu. Tak kisah mana-mana V dia mesti sama.
Okay.
Lagi anything you want to ask? Ada tak nak tanya apa-apa? Tak ada. Tak ada, that's semua faham kan?
I think no, madam.
So kalau tak ada, so hari ini kita bersurai dekat sini. So I wish that good luck and all the best in your coming PSPM. Tolong jawab dengan betul-betul and jangan lupa, class, my advice to you, please remember, tak kisah you erti jawab ke tak erti jawab, tolong tulis formula. Jangan tak tulis apa-apa. You must write something. Jangan tak tulis apa-apa. Boleh tak mesti write something because for our marking kita telah cari markah untuk kamu, bukan tolak markah. You salah tulis pun tak akan ditolak markah. Tapi you tak tulis, kita tak boleh cari markah untuk you. You get what I mean or not? So, tolong write something. Tak kisah you tahu jawab ke, tak erti nak jawab ke, please write something. At least write the formula. Boleh?
Boleh, madam.
Boleh, madam. Boleh, madam.
So, nak tanya apa lagi? Kalau tak ada, boleh tak kita buka kamera sekejap sebab I nak apa? Screenshot sikit. I buat record. Boleh?
Madam.
Ya.
Saya nak tanya satu soalan.
Ya.
Formula bab 5 ni bagi semua ke ada yang certain dia masuk, dia bagi?
Formula tidak akan dibeli dekat exam. Siapa bagi tahu kamu akan dibeli formula? Kelas.
Ada member yang
Tak,
bagi
untuk
tahu.
kimia tak ada formula dibeli ya. Kita hanya beli in the paper kimia yang akan given in your exam ialah list of the constant yang kita belajar, contoh R, Rybert constant. All the constant yang kita belajar tajuk ke table of the relative atomic mass sahaja. Semua formula apa, Rybert equations ke, PV equal to nRT ke, apa lagi yang semua tu tak akan dibeli dekat exam. You kena hafal semua formula.
Okey, madam. 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 Okey
Boleh tak? Hanya constant je dia bagi semua pemala dia. Contoh apa? Ripple equations RH atau 2 constant kan? Atau apa C ke P ke semua tu. H ke hanya constant yang diberi. Formula tidak akan diberi dekat exam. Boleh?
Boleh.
Boleh.
Buka kamera cepat. Just nak screenshot satu je. Suruh buka kamera je terus left dah. Cepat, 1, 2, 3. Cepat. Semua sudah balik college dah. Yang tak nak buka tu apa? Nanti ya sekejap dah, since you tak nak buka, apa tak nak paksa.
Dah buka lah tadi, madam.
Ya, tak apa. Yang I sempat screenshot tu, I sempat tak sempat tu tak apa. Class, I wish you good luck, all the best in your coming PSPM. Please remember to study. Even PSPM kamu hanya tu 40%, tapi it's very important. You tahu PB marks kamu kan? Tolong tengok PB marks kamu and tolong baca sikit nak jawab macam mana semua soalan tu. So please remember, answer all the questions. Jangan leftkan dia empty. You try your very best and then good luck, all the best.
Okay, thank you, madam.
Yes.
Okay, madam.
Kalau ada siapa nak tanya ke, maybe you nak tanya, you boleh tanya. Kalau tak ada, kita boleh left.